Hello, today we're looking at straight line graphs. In particular, we're looking at the gradient of straight line graphs. Now, first question is, what is gradient? The gradient is the steepness of a line. Now, many of you will be used to riding push bikes or going out for walks, and you know the steeper the hill, the harder it is to ride or cycle up. Therefore, the higher the gradient. The gradient is the steepness of the line, how much it turns. Okay, now with algebra we use this expression y equals mx plus c. Y, we're used to being the y coordinate, and the mx plus c refers to the relationship between the x number and the y number. So we can work out y given x and the equation, or in time we can work it backwards as well. But in particular today we're looking at actual graphs and we're looking at the equation of a straight line. Let's break this down. C, you're adding C, you're adding a constant number, and this will be a number. It doesn't always have to be a whole number, but that is the number that we are adding. Mx means what you're multiplying by x. Now why it's m has various different reasons. I've got to read this off my crib sheet now. Okay, nobody actually knows why m. It is convention. It's just been this way for hundreds and hundreds of years. Okay, some people say it's m because it stands for the multiplier. Some people think it's m from the word monter in French, means to climb, as in the gradient climbing. However, some people think it's related to the Greek letter U, but algebra in this sense has its roots in Babylonia and Egyptian mathematics, okay, with the algebraic equations, which we'll be looking at, wrong side, we'll be looking at in the next part of the video, being Arabic. So it's a combination of different cultures and different beliefs combining into the beauty that is mathematics and algebra. And yes, it is beautiful. Right, okay, so let's have a look at these lines. Okay, as normal, I'm going to go through this first and then I'll give you some tasks to do. Okay, now the video is split up into 3 parts. One part looking at it just on a Cartesian grid, the second part looking at it in algebraic algebraic equations, because we've got an equal sign, make sure I get that right, and the third part is looking at the gradient of lines which are off a Cartesian grid and you're given the coordinates. Right, so let's have a look at this. Now, when we're talking about gradient, we are talking about the change in y divided by change in x. So let's just give that a nice highlight there. And this is the gradient. So what changes are happening in y, i.e. how far you're going up or down, compared to how much x is changing, i.e. how far we're moving back and forward. Okay. Now, with these lines, we have to look at the lines and we have to think about what is happening to them. Now, with these, I'm going to do A first, B, C, D, obviously. When you're calculating these, go for whole numbers. It is possible to calculate it with fractions of numbers or decimals of numbers, but when you do that, you are making it far more complicated far more complicated calculation. So you need to get the balance right. And essentially what you're looking for is you're looking for the right angle here, but what you want is along this edge here, that to be a whole number and that to be a whole number. So if I put this on here, you can clearly see I'm kind of, that's parts. Whereas if I move it over there, you can see that the end of that line is exactly on that whole line there. Hopefully you can see that. Can I zoom in a little bit more so you can see that a bit clearer? Yeah, hopefully you can. I will zoom out in a bit. Okay, So, whoops, refocusing. So can you see if I put that on there, how it's on the major line, it means that that is a whole number. And as I move down, oh, good, that number there is a whole number. Okay, so we can see that there's a whole number of squares here and a whole number of squares there. Let me just move that over a little bit so you can just see it a bit more clearly. There we go. Okay, so if we see how much we're going up, now we always work from left to right on this. So we are going up 1, 2, 3. Okay, I'll show that again. We're going up 1, 2, 3. Again, going back here, how far are we moving from left to right? We're moving from left to right 1, 2, 3. Okay, so in the case of this line, the m or the gradient is 1 because 3 divided by 3 is 1. Let's have a look here. Same principle again. I'm looking for a nice thing. Oh, well, look, that goes straight through the 4 there. Oh, and actually that goes straight through the negative. Oops, move it over so you can see clearly. Sorry about that. Oh, I'm hitting the paper. That goes through the 4. That goes through the negative 4. So we know that these are whole numbers. So again, we're going from down up. How far up? 1, 2, 3, 4. How far going left to right? 1, 2, 3, 4. It's 4. So again, that m is also 1. So just kind of put a little line in there so you can just see the difference. So we can clearly see that actually the gradient of both of these lines is 1. For each 1 square we go along, we go 1 square up. 1 along, 1 up, 1 along, 1 up. Okay. Now, you also notice that these two lines are parallel. And when lines are parallel, they have the same gradient. Okay. And again, that's an important feature. Some of the questions are on that. I think my highlighter's running out. Parallel lines have the same gradient. Okay, right, let's have a look at D. Okay, again, we're looking for whole numbers. Right, so that hits on a whole number there. Oh, look, that one hits on a whole number there. So let's find out how far up are we going. We're going up 1. How far from left to right? 1, 2, 3, 4. So in fact, the gradient of this line is only a quarter. You can see that this line here where the gradient is 1 is far steeper than that line there where the gradient is just a quarter. Okay. D. Now, as you notice, the gradient of this line is very different. The gradient is going down. So when we're looking at the numbers going this way, they will be positive. Because we're going down, the x number will be negative. Okay. So we're looking for the change in y, i.e. how far got that the wrong way around. How far we're going that down, and then change in x, how far we're going from left to right. So again, we're looking for whole numbers. So that hits on a whole number, that hits on a whole number there. Okay. If we went to here, we're then looking at fractions. So I'm going to mark this on my graph to help me. So how far are we going? 1, 2. So we're going down 2. Minus 2. How far from left to right? 1, 2, 3. Therefore, the gradient is minus 2/3. And again, sometimes you'll be able to simplify it, sometimes you need to leave it as a fraction. So to recap, pages are annoying me because they're not straight. The gradient is the change in y and divided by the change in x, where change in y is how far up we are going, and if it's a negative number, it's how far down we're going. The change in x is how far we're going from left to right, and again, you're always looking for that left to right, left to right. How far up we go, and again, that could be a negative number. The change in x is always from left to right. As normal, we've got 4 questions here for you to have a go at. You don't have to copy the graph. Work it out, pause the video and calculate the gradients of E, F, G and H. Right, let's check back in and see what we've got. So again, we're finding the gradient. So we're saying that it is M. We're looking for whole number points. We're looking for where it crosses exactly. So that's not on the far there. It's exactly on the 6 there. So I'm going to pick that point there. It's 1. Coming back here, I'm going to pick that point here. So we're looking for the change in y. So how far we're going up. We're going 1, 2 up. How far across are we going? 1, 2, 3, 4, 5. 2/5. No need to change anything. We can write that as a fraction. Same principle again for F. We're looking for coordinate perfect. There we go. There's 1 there. We'll take that point there. We'll take that point there. Again, it's going straight through the whole coordinates. How far we're going up, how far we're going left. We are going up. 1, 2. How far to the right are we going? 1, 2, 3, 4, 5. 2/5. Okay. G and H. Again, we're looking for whole numbers. Well, there's 1 there. Oh, and there's 1 there. Now, in this case, we're not going up with the graph. We're going down. So it's going to be a negative number. How far are we going down? We're only going down 1. From left to right, 1, 2. Minus a half. And H, the final one. I'm going to pick that point there. Oh, there's that point there. Lovely. So again, we're going down. How far are we going down? We're going down 1. From left to right. 1, 2, 3, 4, 5, 6, 7, 8. Minus an 1/8. And just by looking at these, you can clearly see that these gradients are far steeper than these gradients. These two, if we were walking down here from left to right, you'd find it far, far easier than trying to walk up the hill. Okay, so that's it in graphical form on a grid. Okay, now we can also find the gradient just purely from the algebra. Now we talked about M being the multiplier, and in fact what we multiply by x is the gradient. So in this example, y equals 5x plus 4. We haven't drawn the graph. We don't need to draw the graph. We don't need to do any calculations. We can immediately say the 5 is the gradient, is the steepness of the graph. For every 1 we go along, we're going to go 5 up. Same here, and of course it can be a fraction, half, so that would be a lot narrower gradient. 5 is quite steep, half is relatively shallow. And of course it can be negative if the gradient is going down, -4. Pause the video, find the gradient of these three equations. Okay, fairly straightforward on this. Again, the gradient is 3. The gradient is -7. And the gradient is 1/3 because it's the number that we are multiplying by. Okay, the final one that we're looking at